Warm welcome, everybody. Come on in. Get your notebook, pen or pencil. Whatever you want to write with is fine. This is math from a void. Math just coming at you out of nowhere. And today we have a problem from the 1996 AP Calculus AB exam. So give it a look-see. Pause the video, go ahead and try it out. Now this problem is kind of like a related rates problem, or related slopes anyways. We have this parabola. It's upside down. I don't know if you can read that. So this is x minus x squared over 500. And then we have a tangent line at some point. And that tangent line, it's a specific point though. And that tangent line goes through this point, 0, 20. So that's the information we have about this tangent line. We don't have the exact slope per se. We can find the derivative, but we don't have the value of the slope exactly. We just have this point that it goes through. Okay, so as it says, line L is tangent to the graph at point Q. Find the x-coordinate of point Q. So we have to find where on this graph is it tangent. So first let's take a derivative to find out what the slope is at that tangent point. dy dx, it's going to be 1 minus 2x over 500. I think we could just call this x over 250. Okay, good. And that has to be the slope in the equation of this tangent line. So let's set those slopes equal to each other, because another way to get the slope between these 2 points is to use the rise over run method. So this is going to be x comma x minus x squared over 500. And so if we try to find that slope using like y2 minus y1 over x2 minus x1 methods, then we will get the answer. It's going to look a little complicated. So this is going to be x minus x squared over 500. That's my y2 minus 20. That's my y1 over x2, which is just x minus x1, which is 0. So it's going to kind of stay like that. It sort of looks a mess. But we're going to take that and make it equal to our derivative. Okay, so let's actually copy that. X minus x squared over 500 minus 20. And then all of this over x. So what do we do first? It's actually not so bad, you guys. If we multiply both sides by x, you trust the natural thing that you would do in algebra. Multiply by this denominator. And you happen to get x minus x squared over 250, which is kind of similar to the x minus x squared over 500 we have on this side. And then minus 20. Okay, so we're almost there. We subtract x from both sides. And then if we multiply everything by 500, in fact, let's multiply everything by negative 500 to get rid of these negatives. This will be 2x squared, simply. This will be positive x squared, simply put. And this will be, well, times 5 is 100, and then times another 100, that's going to be, plus 10,000. 100 hundreds. So this is going to give us x squared equals 10,000, and if that looks like a big number, it's okay. It's just 100. So this is the x-coordinate where that tangent line must be hitting such that it goes through the point 0, 20. So we're going to put x equals 100. Now, what's the equation for the tangent line? Ooh, how do we write that? That's going to be y minus y value, which we don't have yet, equals m, that's the slope, times x minus x value. Now we didn't find what the slope was. We just set the two expressions for the slope equal to each other. But we can use this simple definition in order to find the slope. All we know so far is that the x is equal to 100. So x minus 100. Let's find the y value. So how do we find the y value? Well, we do 100. We just use the function minus 100 squared over 500. And that's going to give us 100 minus 10,000 over 500, which is just going to give us 20 again. So this is 80. Does that seem right? Seems right to me. Let's see. Make sure I'm canceling these zeros correctly. Yeah, 100 divided by 5 is 20. 100 minus 20, that's 80. So it looks like the y value is 80. This is going to be y minus 80. Oh, actually, you know what? Yeah, I didn't have to do all that. I could have put it in y equals mx plus b format, because we already know the y-intercept b is going to be 20. And then I can just use the slope. But either way, I'm basically here. So let's use that definition of slope from dy dx, which was much easier. If we just do 1 minus x over 250, while x is 100, that means 1 minus 100 over 250. That's 2/5, which leaves me with 3/5. That is the slope. And if you want it in y equals mx plus b format, even though this is totally acceptable, you can say y equals 3/5 x plus 20. That's the equation of that tangent line at point Q. Or is that the point? Point Q, yeah. Okay, part C, kind of wordy. Suppose the graph of this quadratic, shown in the figure, where x and y are measured in feet, represents a hill. There's a 50-foot tree growing vertically. Okay. At the top of the hill. Got it. So at this highest point, which is pretty easy to find where that highest point is because it's symmetric. This thing is. It's symmetric, yeah. We have zeros at 0 and 500, so the middle has to be 250. So not really any mystery as far as the x value there. Does a spotlight at point P directed along line L shine on any part of the tree? Okay, that's just fancy talk for saying, like, does it cut through the tree at all, or is it like angled too high? You know, if that tree is not as big as I drew it, maybe it's like that or something, right? Who knows? At 250, and or maybe the tangent point wasn't drawn to scale, and maybe it's just like it goes too high or something. So question is basically, does the tangent line cut through the tree? So we need to find out what's the top of the tree, or rather where the tree starts, and then we can add 50 to get the top of the tree. But we need to know that distance in order to answer this question, because we already have the line. The spotlight is basically just a fancy way of saying, like, does the tangent line go through it? If you shoot a light straight at it, does it hit the tree? So let's find out what the value is when x equals 250. It's going to be 250 minus 250 squared over 500. Look, don't make your life harder than it needs to be. If you don't know what 250 squared is, that's fine, right? That's fine. Just think about 250. 250 is, well, 250 times 250, I should say. Can I not just multiply it by 2, take that away from the 250, and be left with 125? And this cancels perfectly, so 250 minus 125 is 125, right? So, you know, make life easier. I am like a human calculator, but I don't. Part of what makes me good at this stuff is I'm really good at simplifying things, not because I'm really good at calculating. So that's the bottom of the tree, and the top of the tree is going to be 175 because the tree is 50 feet tall. So if that tangent line goes through any of these ranges of y value when x equals 250, like when the tangent line gets to that spot, then we'll know that it cuts through the tree. So we just have to plug in 250 to the tangent line. We're going to use this tangent line. Come here, you. We're going to say y equals 3/5 of 250. That's the x value. I have a feeling it's going to go through. 3/5 of that, well, 1/5 of that is 50, right? So 3/5 of that is 150. That's in range, plus 20. Yep, it's going to hit the tree. Pretty close to the top. So yes, we'll spotlight the tree. And if you really want to be careful, you can say like 5 feet from the top. You don't get extra points for saying that. Just, I don't know, if you want to clarify. And showing the work that leads to your conclusion, it comes from this, determining the range of the tree, and then using the tangent line and knowing that you have to check to see if that tangent line is going to hit any of those values within that range as x equals 250. And you have to find the 250 as well, so that's important to know where the top of the hill's at, so you know where the tree is at. Okay, so I think that was easy enough. Good, clean family fun. Not too much to be said about that. I will say this is kind of a tricky problem. But one thing about equation of tangent lines that I always want to remind you and emphasize is that you need 3 things for a tangent line. You need an x value, a y value, and a slope. Now this time, they did give us an x value and y value on the tangent line, but it's tricky because it's not tangent at 0, 20. So you can't use the x value of 0 for anything. You kind of can't use that point unless you do this average slope formula. And some of you guys forget the basics, that if you have 2 points, you can find the slope. You get so used to having to take a derivative to find the slope of things, you forget that the slope is represented by the slope of a straight line. Right. Okay, that's enough blab out of me. I'll see you guys next time in some void.